All right, welcome back. Now we've gotten our potentiometer wired and our brushless motor wired. We need to build a program. Just as a reminder, we took the middle pin of the potentiometer and we plugged it into A0. And we took the yellow-orange signal wire going to the ESC and we attached it to pin 3 on the Arduino. So now we should be ready to go ahead and rock and roll some programming. When we program on Arduino, there are 3 main regions. The first region I want to talk about is this void setup region up here. Anything we put between this curly brace and the closing curly brace here is going to run just once at the beginning of the program and never run again. So the things we put in there are things that literally set the Arduino up. You'll see that in a second. The next part of the sketch is the void loop. So anything between this curly brace and that curly brace inside here is going to be looped through over and over again as fast as the Arduino can possibly do it. So the Arduino is meant to be constantly repeating the code over and over and over again. Some programming and for other stuff, the code will just run through once and be done. In the Arduino, it's naturally looping constantly. All right, the last region is outside those two. So anything that's not in the setup or in the void loop, here we can do things like build functions, and we'll see some of that later on in the course. For now, just focus on the setup, which runs once at the beginning, and then the void loop, which constantly loops from that point on. All right. Overall, what we want to do is we want to read the potentiometer's position. And depending on where the potentiometer is at, we want to spin the motor at a corresponding speed. So for me, I've got the black wire going into the 5-volt positive rail. So 5-volt electrons go through the black wire. And I've got the red wire in the ground. So whenever I rotate the potentiometer towards the black wire, the electrons voltages are higher on the middle brown pin. So right now I've got it turned all the way towards the black wire, so there's 5-volt electrons traveling down the brown wire into A0 on the Arduino. If I rotate towards the ground wire, those 5-volt electrons have to travel through that resistive strip longer and longer and longer, decreasing their voltage. So now the electrons on this middle pin are less and less. So now maybe they're like 3 volts now. If I go all the way to the left, they're going to have to travel through that resistive pin, lose all their voltage. Now there's 0-volt electrons traveling through the brown wire, and we can read that on the Arduino. Now the Arduino doesn't show you the voltage of the electrons. It shows you a number between 0 and 1023. 0 corresponding to 0-volt electrons, 1023 to 5-volt electrons, and like 512 to 2.5 electrons, and then all in between. So you have those numbers to work with. All right, now that we've done a lot of background, let's go ahead and get rolling. First thing I want to do is I want to read the potentiometer's value. So I'm going to do what's called an analog read. If you type the command properly, it's analog capital R read. It will turn this green color. And what we need to tell it, and then I did an open parentheses, what we need to tell it next is we need to tell it what pin is it reading. Well, our potentiometer is plugged into A0, so we're going to do A0 here for the pin that it's plugged into. And then we're going to hit semicolon. So what this is, analog read is a built-in function in Arduino. It goes and reads pin A0. So that's a command, analog read pin A0. It's going to return back a number somewhere between 0 and 1023. The Arduino, however, is really stupid. It is going to forget that number the moment it reads it. So this says, hey, go read pin A0. It goes and reads pin A0. It says, okay, 372. It comes back and it goes, oh, I forgot it. So what we need to do is we need to tell Arduino where to store that value. We've got to give it a location to store it in, and that's called a variable. A variable is just a small piece of memory where Arduino can store stuff. And we got to give that variable a name. Let's name that pot for potentiometer and val. This is going to go in front of the analog read, and we're going to put an equals between the two. And when that's done correctly, this should turn black. So this is a variable. It's going to be a little chunk of memory called pot val. And inside that little chunk of memory, we're going to store whatever number it reads. That 312 number, it's going to put it in here. Okay, so an equal sign in computer programming does not mean equals. It's one of the most confusing things. It means something kind of like equals, but not quite. It means take whatever's on the right and store it in the variable on the left. So take this value that you read from A0 and store it in the memory pop val. All right. One of the weird things about Arduino is that when you make a variable, you have to do what's called declaring it first. You have to actually create the variable before you can use it. So every time I want to use a variable like pop val, I'm going to pop up here above void setup, and I'm going to create the variable. In this case, I'm going to create it using the command int space, and then exactly how I spelled it. And I'm going to give it a starting value of 0. So this is called declaring a variable. The int stands for integer. It's a type of variable that we can make. So an integer is a whole number, non-decimal number. So anything we store in pop val can't have a decimal number associated with it, which is fine because analog read returns numbers between 0 and 1023. It doesn't use decimals. So we can get away with this int variable type. There are other types of variables that we'll learn about, but we don't need them right now, so let's not go into them. Next to this, I'm going to put 2 slash marks. That indicates that what is after this is a comment for human eyes, and the computer will just ignore it. So here, I'm going to just say create a variable called pop val. This is going to be so that later on when I go to read my program, if I forget what this line of code does, it's right here. Every line of code you type is required by me, by this course, to have a comment associated with it. We'll talk about some exceptions in the future, but there aren't going to be very many, and I can't type very well. I apologize. All right, so we create the variable called pop val. We set the starting value to 0. You don't have to do this. You could leave it like that, which means it has no starting value. It doesn't matter. Sometimes it's smart to give something a starting value. In fact, I would argue that it's always smart, so you know where it initializes to. And then, yeah, I think everything's good there. And then we're going to add a comment here, and we're going to say this reads A0 and stores the value the 0 to 1023 value in pop val. Oh, I don't like how that breaks like that. Usually it would go off the screen. Let me actually, maybe we live with it. Oh, I really don't like that. All right. The next thing we need to do actually is we got to go set some stuff up. So we're wanting to use this pin A0. When you use a pin on the Arduino, you've got to tell the Arduino, first of all, how to treat that pin, whether it's an input pin, so as information is voltage coming in, or it's an output pin where you're sending voltage out. In this case, we're reading the potentiometer, so that we're going to read the voltage coming in. So up here in the void setup, we're going to need to add a command for setting it up. That command is called pin mode. So we come up here into the void setup somewhere, and we're going to do pin mode, a lowercase p and a capital M, parentheses. We need to give this 2 pieces of information. So 2 what are called parameters, the pin that we're setting up, and whether it's an input or an output pin. So we're going to set up A0. A0. And then we're going to do a comma to separate the parameters, and we're going to say, hey, this is an input, all caps. If you type it correctly, it's going to have teal. Actually, I think I was remiss in mentioning this. At the end of each line of code, you need to put in a semicolon. I think I added semicolons here and here, but didn't say anything about them. Forgetting semicolons will throw an error. It's easy to fix, and you're going to do it all the time. So I'm going to put a semicolon here for this input. So then put a quick line of code saying sets A0 as an input pin. We use input pins for sensors, joysticks, potentiometers, knobs, anything where we're reading something from the outside world into the Arduino. All right, so now we've got our pop val, and we've got it read into here. Well, we want to be able to see if it works. So I'm going to actually plug my device in for the first time. I'm going to take my USB cable here and plug it directly into the Arduino. When that happens, it should pop up here that this is an Arduino Uno. If it doesn't, you have to click and select the device that you want to have used. And then I'm going to use the arrow to do an upload. So the check mark will just check the code for errors. The arrow will actually upload code. And it's working down here, console verifying. I'm going to actually open this up so we can see what's happening. You can see now it's doing a bunch of stuff, giving us some information. And this is that concise readout, not the verbose one. You can see with all the nonsense it gives you. I mean, some of it's probably useful if you're doing something, I don't know. But that's interesting. And now it said download, it's done, it's okay, everything's good, it's on the Arduino. The Arduino automatically starts running the program. And the question now is it working? So I'll turn the knob and see if it's working. Okay, so the problem is that we haven't actually done anything. All we've done is we've read the value, we've read the analog read A0 and we stored it in pop val, but we can't see the memory change as we turn the knob. So we're going to learn a new thing right now. So when you need to see something that's happening in memory that you normally can't see, we're going to use a command called serial print. To use serial print, we need to first open what's called a serial connection between our laptop and the Arduino. To do that, we're going to use a command in the setup, and we're going to call it serial.begin, and we're going to do it at, we're going to send it one second. We have to give serial begin one parameter, and that's how fast the connection should be set. The standard default speed is 9,600 and semicolon. 2 slashes for a comment, and this opens a serial connection between laptop and Arduino. All right. So now that we have serial.begin, if you spelled it correctly, it should be orange at the beginning and then green for begin. We can come down back to our void loop, and after we read the A0 and we store it in a variable called pop val, we can come down here and do serial dot print. Put in a parenthesis, and what print means, I always think of print as like on a piece of paper, but this print means print it to my screen. Print it technically to the serial monitor, which I'll show you in a second. And what do we want to print? Well, we want to print the number stored in the pop val variable. So I'm going to put the variable name here, pop val. So we read analog 0, get that number, Arduino does that, stores it in the variable called pop val, and then we print that variable, that number, onto the screen. Semicolon right here, and then print the value in pop val on screen, technically on the serial monitor. And now I'm going to upload this to the Arduino. When I do that, the void setup's going to run, and it's going to open a connection that wasn't open before, and then it's going to start printing on the screen, and we'll see what it looks like when we get there. Hopefully this works great. So we're waiting. Oh, now it's all green down here. That's good. I can minimize that. I'm going to open the serial monitor, which is a new little window. It's going to connect to the Arduino and start reading data from it. Awesome. And this is the data it's reading. You can see it's constantly cycling through. A confusing thing is when you do serial print, it just prints the same thing right next to the last thing. It doesn't do any smart formatting. So I'm going to come back down here and change the command slightly, and I'm going to, after the print, but before the parentheses, I'm going to put ln. ln stands for line, so it inserts a new line after the thing, so it goes down instead of across. So I'm going to upload that, and let's see how that changes everything. Again, as the program downloads and runs, I can open up the console if I want to watch that happen. You'll get this error message that it can't find the device because the device got turned off and was downloading something. Now we're back up again. Oh, I was sincerely hoping that it would just fix itself. I'm going to close out the console. I'm going to just close out that serial monitor window and open a new one. I was hoping it could reset itself, but apparently it can't. And now you can see, instead of going across, it's going down. It's much easier to read. Now let's see if this works. So right now I'm assuming I'm totally rotated towards the black wire, which I am. As I rotate to the left, towards the red wire, the electrons go farther through the strip, and now you can see I'm getting smaller and smaller values. So we can see that our program is working. It's reading the value on that middle pin, and then it's saving it to a variable and then printing it to the screen. Everything works great. Awesome, that's exciting. It's kind of fun to see your first program do something if that was your first program. All right, at this point, let's hold off there and we'll learn how to do the motor in the next video.